Hello friends, in this video I will explain about some concepts related to set. Okay, as you can see on your screen, mm, first here it is written theory of set. Okay, so we will learn about set and theory related to set. Okay, so first of all we have to define what is set. So set is a collection of well-defined distinct objects. Okay, if we have so many objects, okay, and if that collection of objects is well defined, okay, we know exactly how many objects are there, okay, then that collection can be termed as set. For example, here given books owned by Ramesh. So Ramesh knows exactly, okay, how many books are there with him. Okay, so distinctness means all individual books can be identified. So that's why this is an example of a set. So next here it is notation of set. So notation denoted by capital letters. Generally we denote set by capital letters, just like A, B, C. Okay. So here given A. So A meaning here given this is a form, and there are many ways by which, okay, we can denote set. So the first method for or denoting set, it is by roster or tabulation method. In this method we write down distinct elements, means we write down individual elements inside curly bracket, okay, and those elements are separated by commas like this. Okay, and the second thing which we have to keep in our mind, that when we write down different elements, then we don't repeat. For example, here uh, below 2 times 3 written. So when we have to represent the set, then we don't write 2 times 3, we simply write 1 time, which is here only 1 time. Okay, so we don't repeat elements. Then after second method, it is by definition by intention. Okay, so this is by common property. So this method uses common property to represent a set. So here inside this definition by intention, that is by common property, we use two forms. The first form is description phase method. In this method, in description phase method, we write down or we describe the property by using phrase. Okay, sorry, here it is phrase. So here it is phrase. Description phrase, phrase, phrase method. Okay, here we write down phrase, just like a is natural number. So natural number is a property, so we are using a phrase for denoting this set A. So that's why this is description phrase method. The second is rule method. So in this we write down the rule by which we can describe a set. For example, here given a equals, and whatever we write down the rules or the phrase, we always write down inside curly bracket. So here in this case you can see here curly bracket a, then vertical column or vertical line you can draw, or column you can write down directly, and then here is the rule: a is greater or equals to 0 and less than or equals to 9. It means the numbers from 0 to 9. So now here just below, the distinct elements or individual elements are written here in this. Okay, so this is rule method. Okay, if we write, we represent the set by using rule. Clear? Then after you can see this is the symbol which is used for belongs to. So since 0 is present in this set A, so that's why we can write down 0 belongs to A. Okay, now next here, finite and infinite set. So finite set means contains finite number of elements. For example, here example given, A equals A greater than or equals to 0 and less than 9. It means the number of elements are fixed, just like from 0 to 8 only, because A is less than 9. So less than 9 means it is 8. Okay, if such type of properties are there, then we write like this. And in case of infinite set, so contains infinite number of elements, but whether it is finite or infinite, elements are what, well defined, because here in this case a is natural number and natural number is well defined. So here and natural number, it is infinite because it can go count 1 2 3 4, you can count till infinity. Okay, then after it is about null set. So null set contains no element. Okay, so and it is represented by this symbol phi. An example given, A x is number of human on Venus. So on planet Venus, number of human, so there is no human being on Venus. So okay, so that's why it is a null set. Now next here it is given union or singleton set, sorry unit set, unit set. So unit set, what it is? Unit set means contains only one element, that is if A, here it is, now you can see inside curly bracket there is only one element A, sorry, only one element B, that is, so A is a what, singleton or unit set. Or in phrase method, here it is given A present president of India. So since only one individual can be the president of India, so this is an example of unit set. Then after here universal set. So universal set is a set which contains all possible sets. Okay, for example, all possible set, here if three possible sets are there, A B C, then if U is the universal set, then U will contain all the elements of A, B and C. For example, you can see here U, so all the elements, whatever elements present in A sets A, B, C, so those all elements are present in universal set. Okay, then next comes equal or identical set, or and equivalent set. So first I will explain about equal set, then after I will explain equivalent set. So equal set meaning, let here by example I have explained. So first set A contains elements 1 2 3 and set B contains 3 2 1. Okay, since all elements in A are also the element of B, so that's why these two are equal sets. Okay, so every and each individual means each element of A should be the element of B, and each element of B should be the element of A. So that's why this is equal set. And in case of equivalent set, there should be one-to-one correspondence. It means number of elements should be same. So here, since here 1 2 3 three elements are there, and in B also three elements A B C, so that's why these two are equivalent, not equal, because here individual elements are different. Okay, and this is the way by which we can denote the equivalent set. We can use these two notation for representing equivalent sets. Okay, thank you. So please like, subscribe and share, and press the bell icon to watch such informative videos on mathematics, statistics. Thank you.